Hi, everyone. My name is Alek Sanchez, and welcome to my presentation on identifying overperforming theaters. The objective of this project was to develop a model that, given a set of movie and theater features, would be able to identify which theaters are more prone to overperforming from their average box office, or what I call over-indexing. This data set focuses on 54 films spanning from 2017 to 2019, and included over 200,000 rows of booking information from the opening play weeks. If a specific theater film combination grosses more than the set threshold, that would be considered a 1 classification for this model. The dataset includes a combination of 4 different data sources, 1 of which included theater information, and 3 of which included different types of movie metadata. Some of these movie features included how many locations it played in, its budget, and a count of YouTube trailer views before its opening weekend. This process of matching titles along 4 different keys was one of the biggest roadblocks and challenges I faced for this project. I tried several different methods before getting a match that I liked and was able to associate everything on the same key. From there, I was able to proceed to the modeling process. Once I established a threshold for over-indexing, I was able to dive into the specifics of the data. I parsed through different slices to gain more insight into how particular segments performed given different types of films. First, I looked at the average rate of which all theaters over-indexed. Then I looked more closely at each division. And lastly, looked at the highest and lowest rates for each division and genre combination, just to get an exact look into the data. Through my modeling process, I looked at 27 features, mainly movie metadata, and also 1 hot encoded information from a theater's buying circuit, payer, film buyer, and division it belonged to. My baseline threshold was derived from the average box office from all the rows within the dataset, leaving me with about 0.68 recall score. I focused on recall as I wanted to minimize the false negatives, and I didn't want to miss out on generating extra revenue when possible. As I arrived to my best model, I was able to arrive at a recall score of 0.73. This was derived by using each location's average per genre of the film, so that the threshold was unique to each theater genre combination, as well as standardized the numeric values to gain a better score. I also did some clustering on the movie data, as well as processing the plot overview of each film through a TF-IDF matrix, but that did not yield better results for my model. The class balance was about 120 to 80,000, and undersampling did not yield better results than my best model. Lastly, I tested my best model, the gradient boosting one, on an unseen validation set and received a score of 0.7281. Looking at the top 5 features from this mean decrease accuracy chart, the top features primarily dealt with movie metadata, with YouTube trailer views being the most important feature in predicting a location success, followed by number of runs, budget, and runtime. The theater information, which you can see at the bottom of the chart, didn't seem to have as much of an impact as I thought it would. Next steps. Next steps for this project were to deploy a web app for this tool, where users can select a cluster of information of movie data, and the model will output the top 10 locations given that movie clustering. I'd also like to include more geographic information and theater information to my model to provide more granularity within the model result. Here is a proof of concept of the web application tool that I look to build and how I expect it to be used and presented. Thank you.